All right, once again, time for the question show. Your questions, my answers. As always, wherever you are on the channel, just go ahead and just type in your question. I'll grab a bunch of them and answer them here. Shorter questions are better. I can't really deal with the paragraph theories. So, all right, let's get into it. Kraken1122. Are you looking forward to when we manage to create artificial superintelligence? I have very complicated thoughts on this whole situation, and everyone around me is probably a little bored of hearing me talk about it, but let me sort of break it down like this. I think that artificial superintelligence is, I'm sort of with the Elon Musk, Bill Gates, Stephen Hawking's camp, that it is a very dangerous thing for us to let loose into the universe. And the reality is that because we just don't, what do you do when you make something that is smarter than you and is getting even smarter? You can't control that. And so on the one hand, you'd be like, well, we just shouldn't do it. We should just make like specialized artificial intelligence, just focus on that and not make any kind of general superintelligence. But the problem is that year after year, as the tools get better and better and the faster our computers get, some guy or girl in a garage is gonna make this, right? That you can't police 10 billion people around the world who are going to be working on this kind of technology. So my feeling is that it's inevitable. And so then the only thing we can do is come up with some kind of defense for it, literally race to get artificial superintelligence first and somehow manage the control problem so that you can actually have control over what it does. So I think it is the great crisis that human beings are going to have to face over the next probably 50 years, maybe sooner, like a couple of decades. That's my feeling. Am I looking forward to that? No, I think it's on the scale of nuclear weapons and biological problems. We have some big challenges as human beings to face. If we can get across this gap, if we can solve it, then literally the whole universe is for us to explore and be able to get to, because we're going to have this amazing tool, these wonderful computers that we've somehow gotten under control but can help us figure out how to do all this stuff. So that is both the thing that is going to take us to the next level and is the thing that is quite unnerving to think about. So that's my thoughts on it. Orza. If dark matter interacts with normal mass just by gravity, then shouldn't dark matter have an effect on black holes too, like any kind of pull on them? Absolutely. Dark matter, we still don't know what it is, but we do know that it interacts. It doesn't interact with regular matter in any kind of normal way, but we do know that it interacts with all matter with its gravity. In fact, it is the vast majority of the gravity-producing material in the universe. And so absolutely, it's interacting with black holes. You can imagine a cluster of dark matter having black holes fall, be attracted towards them and fall through them. So absolutely. In fact, one of the sort of kind of fringy ideas, this hasn't been completely disproven, but most astronomers don't believe in this, is this idea that one answer for what dark matter is that it's actually microscopic black holes, primordial black holes left over from the formation of the universe at a time when you could get matter compressed so tightly that smaller kinds of black holes could form. At this point, most astronomers don't think that's the case, but it still could be possible that in fact dark matter is just black holes, tons and tons of tiny little black holes that account for that enormous amount of mass in the universe. Andrew Singleton. Assuming faster than light is impossible and we have no way to cheat the speed of light problem, how hard will it be to colonize our own solar system? It'll be hard in that we're going to have to develop new technologies to be able to launch things into space and to be able to survive in space and be able to utilize the resources of the solar system. But it is definitely not impossible, and there's no laws of physics that would prevent it. In fact, as we build more and more infrastructure out in space, it gets easier and easier to live in space. And I think that it's, assuming that we do continue on our path of space flight, it is inevitable that we will end up colonizing the solar system. We will have orbiting, rotating space stations. We will have asteroids that we have mining facilities on. We will have colonies on various worlds like Mars, maybe things floating in the cloud tops of Venus. I think all those things are, as long as we continue to progress, those things are inevitable. Making that leap to other solar systems that are outside of ours, I don't feel that human beings are going to make that jump, that we will eventually send fleets of robotic factories out there into the Milky Way, and they will start to further colonize the rest of the Milky Way and just give us information back about what's out there. John Wolf. Hey, I love your videos. What are your favorite YouTube channels? I've got a bunch of favorite channels, probably a lot of the same ones as you, right? I really like Isaac Arthur, and I like working with him, and Amy Shira Title, and Scott Manley, and a bunch of things. But I would like to have you tell me what channels we should all be watching. I would love to know about channels that are, covering space and science and technology and futurism and things like that, who maybe don't have a large following and maybe a lot of people haven't heard of. So go ahead and put some links in the comments. Now, I know this is going to trigger the spam filter, so I will be watching, and I'll check the links that you guys do, and I'll approve the ones that clearly aren't spamming, and I'll delete the ones that are somehow spammy. So please let me know the thoughts, and let's just dump in all of the YouTube channels that we like to go to, and then maybe I can reach out and start doing some collaborations with some of these people. So let me know. Jack Hammer 2002. Other than our night sky changing, would the solar system being flung out of the Milky Way have any effect on us? If the solar system was somehow flung out of the Milky Way, you're exactly right, that our night sky would change over time. We would have no stars in the sky. We would have, if we were still close to the Milky Way, we would have this single fuzzy bit that was in the sky, and maybe Andromeda, other large galaxies that were out there, they would, with perfectly dark skies, you would see this hazy fuzzy bit in various parts of the sky, and apart from that, you wouldn't see anything else. That said, there's also one additional theory, which is that the sun, as it goes around the Milky Way, as it orbits around the Milky Way, it appears to oscillate. It kind of rises and goes above and below the plane of the galactic plane. And one of the theories for why we get mass extinctions is when the solar system rises high enough above the galactic plane that it's not protected by literally the galaxy's magnetosphere. Kind of like, the Earth has a magnetosphere and that protects us. So there is a sort of a galactic cosmic rays and particles that are coming, and one of the theories is that as the solar system rises up out of the galactic plane, there's more radiation, and so it might be more dangerous for us to not be within the Milky Way. But apart from that, you just would have a really sad night sky. Peconico 117. Hey, great work. I have a question. If we have a spaceship in the future capable of traveling at the speed of light, immune to stellar radiation and all of that, like in the movies, would it be dangerous to fly inside a gas nebula at normal speeds, not light speed, like Voyager, for example? They're pretty, but are they dangerous? Now, we've done a whole video about how the pictures that you see of the universe are not really an accurate representation of what you would see with your own eyeballs. When you gather light, when you see a picture, it's because the astronomer is using a telescope that's gathering a lot of light, and then they're attaching a camera to it that is gathering that light for a long period of time, for minutes, hours, sometimes even days, right? And so your eyes, as you look into a nebula, you're only seeing, and then your eyes are your meat cameras are dumping out the amount of light every few seconds, and so you just don't build up an image in that way. So the sad truth is that if you were in that spaceship and you're flying through that nebula, you wouldn't even be able to tell. You couldn't see out the window and see any kind of nebula. It wouldn't look pretty. It would just look like regular space. Now, your sensors would know that the space was a little denser than somewhere else. If you went through it at, sublight speeds, no, you probably wouldn't, depending, like whatever your spaceship is capable of traveling through space, you could travel through a nebula like that and not really have any increased damage or radiation or particles bouncing into you in any appreciable way. But one of the big challenges is just being able to travel at significant portions of the speed of light in general, because it is like sandpaper. You're hitting grains of interstellar dust and particles at a significant fraction of the speed of light, and each one of those is like a bomb hitting your spaceship, and so there needs to be a way that you can protect that. And so that is really the great challenge. To then fly through a nebula won't cause any significant difference to it. Jacob Thompson. How plausible would it be for a generational ship to be sent to explore the cosmos? I know that we really, really, really want human beings to go to other star systems. Like, that is what science fiction has told us, that we are going to hop in our spaceship and we're going to travel faster than the speed of light, and we're going to transport down, and we're going to be on some garden world, and we're going to learn the ways and cultures of other aliens that kind of look like human beings, except they got little, things on their noses. But the reality is that for us to travel in space, and as I mentioned in the last question, at any significant fraction of the speed of light, which is the kind of speed that you would have to go to be able to get to even the nearest star systems within a human lifetime, you're going to have to build a spaceship that's capable of suffering a lot of damage. To build a generation ship is one solution, right? Then you create a ship that maybe does the trip in 1,000 years. Right, and multiple generations are born, live, and die on the spaceship while it's making this trip to another star system. But that is a whole other set of challenges, which is like, how do you create a machine, the spaceship, that is capable of continuing to power itself and supply all these resources for human beings to live out their lives, to be able to make this journey. And then think about the ethical issues. Like, is it right to have people be born on a spaceship that then they live out their lives and they know that they're not actually going to be able to reach the destination? Their only job is to keep the machine going. I can imagine some problems. So my feeling is that we are going to probably never send human beings to another solar system, that it's going to be the robots. So we're going to send the robots, they're going to make more robots, they're going to explore the cosmos. And there could be some new break in physics, like be it wormholes or faster than light, that we will figure out that will make all of this wrong, right? And that, maybe down the road, we will set up galactic infrastructure, that there will be like really powerful laser systems that accelerate solar sail vehicles to a significant fraction of the speed of light. And then you've got another set of receiving lasers at the next star system, and they break a starship that's coming in at 10% or 20% of the speed of light. And so maybe if we really figured out all the technology and built a ton of infrastructure, then maybe we could get people from star to star. But in all of the ways that I imagine it right now, we are looking at hundreds and hundreds of years before we can try and attempt that kind of stuff, in my opinion. David Schaefer, what do you think of games like Space Engineers or Kerbal Space Program? What do they get right, and which level of civilization would those games be at? I haven't played Space Engineers, so I don't know, but Kerbal Space Program, they're at our level of technology, which is kind of the wonderful thing about the Kerbal Space Program, right? Is that they use all the same kinds of technologies, rockets, aerospike engines, the various kinds of landers and rovers and power generation and all that. But what it is that the Kerbal Space Program has the funding and the willingness to explore and colonize their own version of the solar system. And that's the difference, is that it's got the political will and the sort of the financial will to make this happen. And I sort of love that idea. So I wouldn't put that one. Space Engineers, I haven't played. It's probably maybe someone can post that in the comments. A Clever, your thoughts on a laser relay system for getting around the solar system faster? Obviously, someone would have to lay the relays. My guess is the first ones would be the moon, Mars, and the belt in a few places. A laser relay system, I think, is going to be the most important piece of infrastructure that we set up within the solar system. And so you imagine, right, you've got these great big lasers that are in orbit around the sun, or orbit around the Earth, or orbit around the moon, or whatever. And they have the ability to power themselves with solar power. They build up a capacitor, they build up their batteries, and then they can shoot this laser at some kind of solar sail spacecraft and give it a thrust and be able to boost it into a higher orbit. And you can imagine, as this thing comes around, another laser tracks it and picks it up and zaps it and increases its thrust again, and then another ones will zap it and decrease its orbit. And so you can imagine this future solar system where you don't really have to take fuel, you just rely on this relay of lasers around the whole solar system to kind of go wherever you want to go. And these things, some will be able to be capable of boosting small payloads very fast, others will boost larger payloads more slowly. I think that is the future. And as you said, we'll start with closer to home, we'll learn how to do them, and eventually, as we build, it's like building the railways at the beginning, of the last century, where you built that railway network across the United States, and now you can get further and further into the country more quickly. What used to take you years and was very expensive to cross the country takes you a week, which is kind of amazing. Michael Murphy, what would happen to a stone if it fell into the sun? It would boil. So the temperature of the sun, of the surface of the sun, is about 5,800 degrees Celsius, I think. And rocks are made of, say, silicon oxide, and they would melt at 1,200 degrees Celsius and boil, or 2,200 degrees Celsius. I'm just doing this off the top of my head, I think. So you would drop a rock in and it would hit the surface and it would just evaporate into a cloud of silicon oxide, and it would join the sun. And it would probably, the heavier elements would fall down into the sun and join the rocky elements inside the sun. There is, in the sun, multiple planets worth of iron and silicon and all of these things that would make up planets. It's just that the sun is so hot that they're all just turned into plasma. Marcus Harma. So the more gravity is, the slower the time passes. If so, how does time pass in areas between galaxies that have zero gravity? This idea of time dilation near massive objects like black holes only occurs when you're close to the heavy gravity. So if you are in an area where there is no gravity, then you experience no time dilation. All right, well, we had one more question, but we're not going to do the question now because all of the lawn machines around us have decided to go off. So I'm just going to say goodbye. Thanks everyone who answered your question, asked me your questions. Go ahead, wherever you are. I'm just going to get louder. Just go ahead and put that question into the comments, and I will scoop them up and I will answer them here. We'll see you next week when it's quieter. Orbiting, rotating, solar, let me do this again.